Welcome to my lecture online. So what do we do with a problem like this? Well, we're going to do it the same way we did the previous problems. We're going to start with a simple direct relationship and build up and see if we can find out what the exact direct variational relationship is between the variables y and x. So we're going to start with the simplest one. If it's a direct variation relationship, we get y is equal to k times x. And let's see what we can find here. We're going to first find k and then check to see if all four or both the two sets of values will satisfy that equation. So first let's find y equals 24 and x equals 4 and plug it in here. So we get 24 is equal to k times x, which is now 4. Divide both sides by 4. And we get 6 is equal to k. So that means that our equation becomes y equals 6 times x. And let's see if that one satisfies the other set of variables. So we plug in the 81 and the 9. So we're going to do a check on that. And so y is 81. 81 is equal to question mark 6 times 9. And of course 81 is not equal to 54. So we did not get the correct value or the correct equation. All right, now our second equation, let's try y equals k times x squared and see if we get the correct equation there. First, we need to find k, so we plug in y and x. So we get 24 is equal to k times x, which is 4 squared. So 24 equals k times 16. Divide both sides by 16, and that becomes 1. And here 24 divided by 16 is 3 over 2. So there we have another value for k. Let's plug that into our new equation. We get y is equal to 3 over 2 times x squared. And now we're going to do a check by plugging in the other set of values for y and x. So when y equals 81, is that indeed equal to 3 over 2 times x, which is 9 squared. Let's see here. We get 81 is equal to 3 over 2 times 81, question mark. And the answer is no. Again, we get a wrong value. But notice what happened. Here when I tried, the left side was bigger than the right side. Here, the left side is smaller than the right side. So I've actually went past the point where I would find the correct equation. Here we had y equals k times x, and here we had y equals k times x squared. And it's somewhere in between the two. Maybe it's x to the 1.5 power, which is 3/2 power. Well, let's try that. So we have y is equal to k times x to the 3/2 power. So halfway in between x to the first and x to the second, because it has to be somewhere in between. All right, let's try that. Again, we're going to find k by plugging in the values 24 and 4. So 24 is equal to k times x, which is 4 to the 3/2 power. So on the right side, we first take the square root of 4, which is 2, and then we cube it, which is 8. So we have 24 is equal to k times 8. Divide both sides by 8, and we get 3 is equal to k. So now we have a new value for k. Notice that the value is in between these two values. Now let's plug that into the equation. So end up with y is equal to 3 times x to the 3/2 power, and we're going to do a check on this. All right, plug in the second set of values. 81 is equal to question mark 3 times x, which is 9 to the 3/2 power. So here we first take the square root. The square root of 9 is 3. 3 cubed is 27, so it's 81 equal to 3 times 27. And of course, 3 times 27 is indeed 81. And so therefore, there we go. We got the right value. So this here became the correct equation that we're looking for. And here you can see that on this try, the left side was bigger than the right side. On this try, the left side was smaller than the right side, so we knew it had to be somewhere in between. It was not x to the first power, it's not x to the second power, somewhere in between. And so we tried x to the 3/2 power, and that happened to be the correct value. And that is how it's done.
We're just guessing.
It's a guess game here, but stay tuned because now we're going to try a more elaborate method on the next example.